This second type of problem we've got here in 14.3 presents itself differently, but it's really pretty much the same problem we just did on the first one. I didn't come up with a great title here. I called it Finding Trig Ratios, and I probably should have said From Other Ratios. So let's take a look at what we've been given in this problem right here. They're telling us here, guys, that if the tangent of theta is equal to this value here of 4 over 9, let me give myself a little bit more room right here. Okay, oh, that was weird. 4 over 9, we're supposed to find the cosecant of theta, and in two different cases here. First of all, if theta is in quadrant number 1. Okay, so let's take a look at what we're dealing with here, guys. We have ourselves, just like always, the same setup right here of an x-axis and a y-axis and a unit circle, and we're dealing with an angle here in the first quadrant. And what's great about the first quadrant is that both x and y are both going to be positive values. Now, they told us here that the tangent of angle theta is 4 over 9. So let's remember, everybody, that the XYR definition of tangent of any angle is going to be y over x. And that means that if my tangent value is equal to 4 over 9, well, right here I can read from this, guys, that x, my denominator, is equal to 9, and that y, my numerator, is equal to 4. That means that, in a way, this really is a terminal side problem like we did before. All we're missing is r. And how are we going to find that? Just like in the last problem, guys. We're going to do the Pythagorean theorem here and try to figure out the value of r from the values of x and y. So once again, guys, always, it's going to be x squared plus y squared is equal to r squared. Our x value is 9. Our y value is 4, and we don't know what r is. Probably best to just dump that whole thing into your calculator at once. If I'm doing it mentally, I'll do it piece by piece. 81 plus 16, you'd end up with a 97 is equal to r squared. 97 is an ugly number. I believe it's prime, but it's definitely not a perfect square. So we'll go to take the square root of both sides, and I think all we can do with that, guys, is say that r is equal to the square root of 97. So, okay, that's what r is, I guess, the square root of 97. And now we're supposed to figure out what the cosecant of theta is. So, back to what we talked about in the previous problem, cosecant is the reciprocal of sine, and sine, hopefully we know, is y divided by r. Cosecant, then, is the other direction, r divided by y. So, cosecant is going to be the square root of 97 all divided by 4. And actually, this worked out well for us. Because we're doing cosecant instead of sine, the ugly, irrational radius right there, the square root of 97, ended up in the numerator of our fraction, which means we don't have to rationalize this denominator, which we would have had to do if we were finding sine. Now, I didn't pay any attention yet to the fact that I said here that theta is a first quadrant angle. And what's great about the first quadrant, as we said, everything is positive there. X and y, so both cosine and sine, and tangent as well. So these are the correct values of x, y, and r if we're in quadrant 1. But then if I go down here and look at example B, which for some reason is showing twice there, that's very strange. Oh, hey, it went away. Anyway, if I take a look at that, okay, great. Now what happens if theta is in quadrant number 3? So there's actually very little new work to do here, guys, but now if we're focusing on the third quadrant, what's unique about the third quadrant here? Well, in this case, guys, x is going to be negative, and y is going to be negative as well. But actually, that's about the only change that we have here. So my x-coordinate, which had been 9, is now going to be negative 9 if we're in quadrant 3. Our y-coordinate, which had been 4, is now going to be negative 4. But here's the cool thing here, guys. The radius, as we've said many times before, is always going to be positive. That is still the square root of 97. And what we were given right here, guys, still holds in the third quadrant. Tangent is the quotient of y divided by x. And in this set of numbers right here, tangent would be a negative 4 divided by a negative 9. And a negative divided by negative still gets us a positive. So I couldn't have done this problem giving you quadrant 2 or quadrant 4 here, but I can in quadrant 3 because tangent is still positive in quadrant 3 just like it was in quadrant 1. In both of these two quadrants, x and y have the same sign, and when you divide positive by positive, or negative by negative, you're still going to end up with a positive value for tangent. So all we had to do is kind of change the signs of some of these values, and then we're going to be able to answer this question lickety-split. Cosecant of theta, once again, you guys, is r divided by y. Well, in this case, r is still the square root of 97. Y is now negative 4. So I'll put the 4 here and the negative out in front, and I'll box that one up right there and call that good. Probably should have left myself a little bit more room. So the big difference here, guys, is that cosecant, which is the reciprocal of sine, would be positive in the first quadrant, but it's now negative in the third. Okay, that kind of takes us through two different variations of really the same type of problem. Now, ironically, let's go back a year in time. Let's go to geometry, guys, and talk about solving right triangles. So what we've been given here, hopefully this is obvious to see, is a right triangle, and 3 measurements have been given to us, guys. We have a leg of 7. We have an acute angle right here of 36, and we were given the right angle here of 90 degrees. In every triangle, there are 3 measurements, 3 side lengths and 3 angle measures. And 3 of those have to be given to you in order to determine one unique triangle. Now, when they use the vague directions of solving a right triangle, what they mean is find the measure of everything that wasn't already given to you. So what do we need to know here, guys? For angles, all we need is the measure of angle A. So I'll just put a little line right here just to remind me that that's something that I need to find. I also need the other 2 side lengths. And if you guys remember the naming structure in a right triangle, if this angle up here is capital A, then this side across from it is lowercase a. So we've got to come up with the length of that side. And then if your right angle is capital C, your hypotenuse then is going to be lowercase c. So as we said, every triangle has 6 measurements. 3 of them were given to us here. We've got to come up with the other 3 in order to solve this right triangle. So let's talk about how we're going to do that. Well, the first thing I'm hoping you see is nice and easy right here, guys. The measure of angle A. In every triangle, we know that the sum of the 3 angles is 180 degrees. Always, always, always. So, if we know that 2 of the angles here are 90 and 36, all we would do is go to our calculator, and I would try to do this in one step, everybody. Take the total of the 3, which is 180, and then subtract the 2 that you know. We had a 90-degree angle, and I believe that was a 36-degree angle. I better check that again. It was. So let's type all that in at once, and that gives us our third angle now of 54 degrees. So that wasn't too hard to come by. Gotcha, gotcha, and there we go. There's other ways to do that as well, but I think that's the most direct. Okay, now we have to figure out side lengths now. Pythagorean theorem doesn't help you here because we only know one side length, so we've got to use some basic trig. So what we're going to do is envision ourselves standing here at the 36-degree angle. And 2 ways we could go with this one. Yeah, I suppose either one's fine. We're going to try to use a trig ratio that uses the one side that we know, 7, and then the A, the side that we're looking for. So from your standpoint, 7 is going to be the opposite leg, and A is going to be the adjacent leg. So we just have to ask, this is back to geometry now, in the old way of looking at sine, cosine, and tangent, which trig ratio uses opposite and adjacent legs? SOHCAHTOA, this is tangent. So this setup is going to be the tangent of 36 degrees equals opposite leg of 7 over adjacent leg, which is A. So there's the equation we have to solve. Now this is probably the trickiest case here where the variable is located on the bottom of your fraction. So when that happens, guys, we just switch the left side of the equation with the bottom of the right. That now becomes A equals 7 divided by the tangent of 36 degrees. And that is all we have to type into our calculator. But wait a second, guys. You need to make sure your calculator is in degrees before you type this in. For you guys on the TI-84, up in that status bar, top and then almost to the right, you should see the word degree written out. If you see radians, you need to go to mode and change that. For my calculator, if you guys look over on the left, the top left corner, right underneath that 1.1, it says DEG. So I'm in good shape here, guys. I'm in degrees. And we need to type in, I forgot already, 7 divided by the tangent of 36. So here's a 7 on top. divided by a tangent of 36 on the bottom. And when we hit that, we're going to get an answer of this. We're going to round to 2 decimal places today, guys. That's going to be 9.63. So I'll write that one down. Now, before you go ahead and just assume that this answer is right, I want you guys to take a look at the triangle and tell me if you think that's a realistic answer or not. It is. But unfortunately, a lot of people say, yeah, A might be 9.63 because A looks like it's longer than this leg right over here. And that's precisely the wrong way to look at things. The really important thing, you learned this in geometry last year, we've talked about it earlier in this unit, the measure of angle A we found here, guys, was 54 degrees. That means that angle B here is the smallest angle in the whole triangle, and what's across from it then, 7, has to be the shortest side. Since 54 here is bigger than 36, A has to be bigger than 7, and that's what we found. Okay, we need to find C at this point, and now if you wanted, you could use the Pythagorean theorem, but I really don't recommend it. That would require you to use the value that you just came up with for A in order to find C. And that means, guys, that if we made a mistake here, then C would automatically be wrong as well. So I'm going to go back and do trig again from the 36-degree angle. Now, 7, still my opposite leg, but C is my hypotenuse. So let's start all over now, guys. Which trig ratio uses opposite leg and hypotenuse? That's going to be sine. So the sine of 36 degrees is my opposite leg, 7, divided by my hypotenuse, which is C. Once again, my variable is on the bottom of the fraction, so I'm going to flip-flop the left side, the entire left side, and the bottom right. So we're now going to get C is equal to 7 over the sine of 36 degrees. And as we go to our calculator, let's think already of what to expect, guys. C is our hypotenuse. So absolutely, without question, C needs to be the longest side in this triangle. So it's got to be longer than the longer leg, which was 9.63. So I'm expecting something bigger than that. 7 divided by the sine of 36. Let's type that in and see if we get something similar to what we expected right there. Yeah, 11 point, that would be 9.1 if we're going to the nearest hundredth right there. So 11.91 is what we're going to put right there for C, and there it is, everybody. We have solved this right triangle. We now know the measures of all 3 angles and all 3 side lengths. Okay, so that's how we do a problem like that. One more now, guys, and this one is just a little bit different in what was given to you and what we need to come up with right here. So what do we know and what do we need to find? It looks like, guys, in this case, we were given 2 sides and 1 angle, as opposed to the previous problem where we were given 1 side and 2 angles. So I don't know if that makes this harder or easier, but we'll figure it out either way. All right, guys, we need to come up with here the measure of angle A. And by the way, it's kind of childish right there. You really could just put capital A equals. It's understood that a capital letter means an angle. We need the measure of angle B. Got it. And we were given the 2 legs of this triangle, the 5 and the 11. We've got to come up with the hypotenuse. Now, again, since our right angle here is called capital C, our hypotenuse then is going to be a lowercase c. All right, so those are the 3 things we need to find before we can move on. All right, guys. So when you're in a problem like this, what I would do at this point here, guys, is I'd try to find angle A here first using the 2 sides that we know. 5 is your adjacent leg. 11 is your opposite leg. So this is a tangent problem. The tangent of angle A, which we don't know right now, is equal to, and notice, guys, I'm going to leave a little space before I write this fraction. Tangent is opposite leg over adjacent leg. That's going to be 11 over 5. Now, where's your variable? Right there. The variable is the angle now. What's being done to it? We're taking the tangent of it. And how do we undo that? The inverse operation of tangent is just called inverse tangent. And of course, you can do whatever you want to the left side of an equation as long as you do it to the right side as well. So that's why I left some space before I wrote that fraction of 11 over 5. Now, as you'd expect, inverse tangent and tangent are going to cancel each other out, and we'll just get A equals, and now it's calculator time. We're going to ask the calculator what angle out there has a tangent ratio of 11 over 5. Now, think for a second before we type this in. Should we get an A value more than 45 degrees or less than 45 degrees? Since 11 is the longer of the two legs right here, that means that angle A has to be larger. Let me make that a double tick mark, even though that doesn't really mean anything. Larger than angle B. B has to be the smallest angle in this triangle, which means it has to be less than 45 degrees. A is going to be the larger of the two acute angles. It should be more than 45 degrees. All right, guys, inverse tangent of 11 over 5. For you guys, it's going to be second tangent. For me, I think if I just hold that down, there we go. Inverse tangent of 11 divided by 5. All right, and let's hit enter now, and we're going to get 65.56. That's kind of a cool number. Got some nice symmetry to it. 65.56. We were expecting a number bigger than 45 degrees, and we got that. So let's write that down here. 65.56 should put a degree sign after that, and there's angle A. Now, really good news, guys. I'm not going to make you sweat to find angle B. Once you know the measures of two angles here, and we now know angle C, which is 90 right here, and angle A, it's real easy to find B. So for B, I'm going to take the total, 180, minus the 90-degree angle, and minus the 65.56 that we just came up with right here. So that's going to be a 180 minus 90, and then minus, guys, second answer is probably the easiest way to do this. You could also hit the up arrow and hit enter right there, and that'll work too. And we got 24.44 for angle B. All right, so I guess I don't need to write that here because I'm about to write it here, but there you go. So once more, guys, just like in the last example, once you know two angles, it's just subtraction to find the third. I'm not going to make you do all that trig again to find something that we could come up with relatively easily. And what's missing now? Our hypotenuse of C. And you've got two different routes you could go right here, guys. Since you know two legs of the triangle right here, you could do the Pythagorean theorem, or you could use trigonometry as well. The only problem with trig is it requires using an answer that we just came up with. Like, for example, if I do this with B, and if I made a mistake in finding B, that means then, everybody, that my answer for C is going to be wrong as well. So, honestly, the Pythagorean theorem is probably the safer way to go. Let me show you what that looks like, but maybe we'll come up with the answer both ways. So leg squared, 5 squared, plus the other leg squared equals your hypotenuse squared. Let's see, 5 squared and 11 squared, that's a 25 and a 121, so it should be a 146 is equal to C squared. I should probably check that before I goof it up. Let me think here. 5 squared plus 11 squared. I'll never doubt myself again. All right, is 146, and now, I lost it. There we go. And now we would take the square root of both sides right here. Now, 144 is a perfect square. Its square root is 12. 146 is just a little bigger than that. So I'm expecting a number slightly bigger than 12. So the square root of 146, rounded here, guys, 12.08. So that's what I came up with here for C. Feel pretty good about that answer. I knew that C had to be bigger than 11, and 12.08 seems to fit the bill. You can stop listening to me right now if you want. We could have done this problem another way. We could have said, just for example here, guys, that the sine of angle B, which was 24.44 degrees, was equal to, all right, guys, sine of B, if this is where you're standing, is opposite leg, there you go, over hypotenuse. So the opposite leg here would be 5, and the hypotenuse, let's just say it was unknown, was C. Flip-flop the top left and the bottom right, you'd get C is equal to 5 over the sine of 24.44 degrees. And if I did this really, really carefully, I should get the exact same answer here. Here's what I'm going to do, guys. Otherwise, this gets a little bit ugly. I'm going to go up to this. Let me try it without it. Let me see if we can do this here. You might be able to do this on your 84 too. 5 divided by, all right, let me write this out as a fraction. So, no, yeah, 5, all right, over. And then if we did the sine of 24.44 degrees, ooh, if I do that and hit enter, now see, it didn't put that where I wanted it to be. All right, I was a little worried that might be the case. What if I did 5 divided by the sine, and now I went up, 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 and hit enter? That should work. All right. I want you guys to notice the answer I got doing it that way with trig isn't just kind of close to the answer that we got using the Pythagorean theorem. It is exactly the same. It is accurate to 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's 10 decimal places. So long story short, I feel really good about that answer, and that's how we solve for that right triangle. All right, guys, so that should walk you through pretty much everything we need to know from 14.3, but my hope would be that these last two problems you already knew how to do. And number 1 and number 2, just a little different way of presenting information here, but it's something you probably knew already as well. So hopefully 14.3 isn't too tough for you on that homework, so give that a shot, and good luck, everybody.